Anybody? Let's see, in this first row, anybody?
What?
74. 72, 73. I'm sorry, I skipped 73. Anybody? It was an equal sign. Eli?
No.
For 73.
73, yes. What did you get?
X equals -7 and X equals 13.
Yes, x equals a -7 or x equals 11. Zach, do you have it done on a piece of paper?
Yeah.
Why don't you bring it up? Let's just try and move through these quickly. Is there anything? So let's see the original equation. That's 72, 73, right below it.
Or 73.
Right there. Move it up, 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 up.
Okay.
What did you do?
So I did it the way we did that problem, and actually never mind. So I minus 1 and I don't know.
You got your absolute value by itself.
Yeah, and then I solved for x, and then there's the and then for the number line, I just made it's not greater than it's not an inequality, so I just made 2.
Like motion
Yeah, you can't. You gotta just leave it. Leave it alone. Yeah, Zach.
Okay, I got it. So I just made 2 points.
Okay. All right. So wait, don't move that. Put that back. Put that back. We're still talking. Okay. So tell me, what was your question, Eli?
I don't think I can find it.
Here, I'll get it. It was which one? 73. Where's 73?
There.
Okay. Okay. Thank you. Can we just leave that there for a second? Eli, what's your question?
How can -10 equals absolute value of 2 minus x plus 1 like ever equal and negative?
Okay. What are we dealing with? Why are we setting it up the problem that way? No, this one isn't an inequality. This one is an equality. But why are we trying to solve the problem twice? Because it's absolute value. So it's possible that when you go back, remember, you always go back to the original problem. And problem number 73, let's see, is this the original problem, 10 equals? 10 equals the absolute value of 2 minus x plus 1. And so he said when x was a -7, I'm going back to my original problem, 2 minus a -7 plus 1. 10 equals, what's going to happen here? It's going to be plus 7. So it's going to be 9 plus 1. And this comes out as 9 plus 1. It works.
Look how the negative works.
Okay, so now I'm going to go back and do the same thing. So I'm going to plug in what for x? 11. 10 equals absolute value of 2 minus 11 plus 1. 10 equals the absolute value of a -9 plus 1. 2 minus 11. We did make it a negative when we were solving it. But once we have found our value of x, I go back to the original and I test it. And we said that x was equal to 11. We solve it. It comes out of the absolute value box as a positive. And this is a true statement. Okay? Does that make sense to everybody? Okay, so we're doing absolute value. We're doing it for one variable because they've given us the y value really here. And we're just solving it twice because of this funny stuff that happens inside of the absolute value box. Okay? All right. Thank you, Zach. That was a nice job on that. Okay? All right, that was, what number was that, 73? 74, let's see if we can just move this along. I'm just gonna read them out. 74. So unless we have questions, I'll let somebody else do that one. 74 is x is equal to a negative 3/4 or x is equal to 5/4. And since we're graphing them, they're equalities, I know that they are solid circles on the x number line. Okay? Yes, no, anybody have any questions on that one? Pardon me?
Neither did I, but I see what I did wrong on it.
You understand what you did wrong?
Yeah, I added it instead of dividing by it.
Okay. Daniel, do you see where your mistake is? You're good? Okay. Anybody else have a question on that one? Okay, that was 74. We're going up to, okay, 75. Okay, let's check to see if you have that. X is going to be greater than a negative 3/2 and less than 5/2.
Neither did I.
Not what you got for number 75?
I got that.
You got that? Stephen, you want to bring your paper up and let's see what you got?
Oh, maybe that is what I got. Hang on.
Let's see if I can do this.
Put your finger on it. Find your hand, find your finger, there it is. It's coming, keep going up.
Keep going.
You go, there, down, up.
Oh, step.
There you go, perfect.
There you go.
Okay, stop touching it.
Yeah. Okay, thank you. So Stephen, you want to just explain what you did?
Well, since it's already in the form, I just went straight to changing it. This would be a line right here. And so you would change the thing to negative 12 and 12 and switch. Then you would add 3 on both sides, which it's just the usual concept.
Okay.
I don't really know how to explain this.
Did you see your errors, whoever did not agree with that? Yes, no? Cassie, were you okay with that?
Yeah, I just didn't reduce my fractions.
Okay, good.
Is it okay if you change it into a whole number, like 2.5?
Yeah, you can. Some people like to do that, but
Do you prefer
preferably an improper fraction is fine. When we do our computations, it's often easier just to leave your number as an improper fraction in simplest terms. Daniel, are you okay with these? Not Daniel, Matt, you're behind you.
Yeah.
You okay with these? All right. So do you want me to continue going over these one by one? Or do we, how are we going to go? We don't have a lot of time. So does anybody have any questions on 72 through 80? Okay, because unless you have those, I'd like to go and look at 40 through 48 evens. 46 on this? Yes. Okay, 46. Okay. Holy cow, 46. And that was on page 147. 147, number 46. Okay, I want you, everybody, let's look at this carefully. Okay. This is one of those think problems. Think. All right, so I'm looking at this and I'm thinking, I wonder if I could move this 3 down the road a little bit. Is this the same absolute value? Okay, would you agree? Okay, you should be able to visualize what this looks like at this point. Is the V pointing up or is the V pointing down?
Down.
How did you know that? It's negative. Okay, on the x-axis, all right, let's look at this 13. Is it going to be a wide V or a narrow V?
Narrow.
Very narrow. Okay, do we know where it's going to be on the x-axis, on the right or the left?
Left.
On the left. Okay, but is the vertex Where's the
It's gonna be
vertex?
Up 3.
Up 3. So I've got a lot of lines going on here, sorry, let me see if I can get it hard.
Logan Coles, please report to the front office.